Dan Perry here with another C++ tutorial for Dan on Tech. In this video we will look at integer math and integer math operations. So to start with, what I'm going to do is I've created a couple variables. I've also created some couts just to save some typing. So let me paste those in. And we've created, as you see, three integer values, inum1, inum2, and inum3, and then couts for each of those. And what we're going to do is we're going to just go in and give a couple of initial values to these. So inum1, let's make it 5. Inum2, let's make 7. And inum3, let's make 0. And we're going to end up using inum3 to store the results of our calculations. So first, let's do a simple addition. So I'm going to say that inum3 is equal to inum1 plus inum2. And I pointed out before, the equal in this case is not equal. It means assigned to. So you take the value on the right, or the calculation on the right, do the calculation and put the results into the value on the left. Now, so that I remember, or we can easily see what calculations we were doing, I'm going to also just copy that calculation here inside the quotes in this cout for it, so we know what we did. And when we run it this time, if we're just adding the two values, inums 1 and 2 should be 5 and 7. We're not changing it. Inum3 should have a value of 12 when it adds it up. So we'll go ahead and run this and look at our results. And here we've got our 5. That was the first cout where inum1 was still 5, and then 7. The third cout, after it did the initialization, it did the calculation. Inum1 plus inum2 is equal to inum3, so it came up with a 12, and then it output there. So nothing unexpected, I hope, there. Let's now, maybe make it a multiplication. So if we multiply the two together, it should now do the 5 times 7 and should give us a 35. And so we'll run that. And you can see that it did give us a 35. This time it multiplied the two together and then gave us the result of 35, which is what we would expect. Okay, nothing surprising there. Now, here's where we need to be careful with in dealing with numerics or integer values. I'm going to go in and I'm going to do a division, and I'm actually going to, let me change the order. Let me do inum2 divided by inum1 the first time, and let me change the output part in the quotes so we remember what we've done. And this time we're doing inum2 divided by inum1, and we saw, or could see from the floating point numbers, if we did 7 divided by 5, we would get something along the lines of 1.4 with floating point numbers. But when we do this with integers, watch what we get. Well, 5, it says 7 divided by 5, and, well, 7 divided by 5, it says 1. Well, not 1.4. Well, it gives us 1 because this is an integer value, and an integer value gives us an integer result. Now, I'm going to copy this cout real quick, and I'm going to change, and let's do a calculation where we say 7.0 divided by 5.0, which are floating point numbers, and I'm just going to put the calculation here outside the quotes. What's in the quotes, remember, is just showing us what we've got. So 7.0 slash 5.0, and those are floating point numbers, and this would be the same as if I had declared a float or a double, and on that float or double I had then done the calculation. So if I had done 7 divided by, or say some float number, F number equals 7 divided by 5 that were floating point numbers, I get the same result. So let's look here, and when we run it, when we did the integer division, we still get 1, but now when we did the floating point division, we end up with 1.4. So be aware that whenever you're doing calculations with integers and you're doing divisions, it's doing whole numbers, so you will not get a decimal value. Okay, now let's turn the tables a little bit, and let's now do 1 divided by 2. So we'll basically reverse those, and now we're going to do 5 divided by 7. So now we're going to do the 5 divided by 7 as integers. And I'm going to, let's see, I'm going to go ahead and change my floating point version as well, so you can see the difference between a floating point and an integer version of these. And when we run it, notice that dividing 5 divided by 7 integers gave us 0. Well, think about 5 divided by 7, that will not go a whole number. That's less than 1 time, and we see that in the floating point version where it gives us a 0.7. Remember that we're dealing with integers or whole numbers, so we don't see any fractional portion. So all we see is the 0 portion of that division with integers. So this is one place you've got to be very, very careful when you're dealing with integer values, is anytime there's a division involved, you're going to get results that may not be what you expect. So know that that happens. Now, when we talked about the different math operators, I mentioned another math operator called the mod or modulus, and we use that as a percent sign. A percent sign, if I could hit the right key. And so now I'm going to do 1, or I-num1, which is 5, mod or modulus 7. And the modulus gives us the remainder of an integer division. The modulus gives us the remainder of an integer division. So when we run that, in this case we get a 5. We're saying 5 divided by 7 goes 0 times with a remainder of 5. And so the modulus gives us the remainder. And just to show the other way around and what we end up with, remember when we did it, the 7 divided by 5, when we just did the integer or the regular division, what we had was a 1. We had a 0 when we did the first way, when we did 5 divided by 7. Now if I run it, now I'm taking 7 divided by 5, and the mod or modulus, the remainder of that is 2. So 7 divided by 5 goes 1 time with a remainder of 2. So the modulus, that percent, gives us the remainder of an integer division. Now, just like with floating point numbers, the parentheses work the same way. Thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss future videos. Please check out and subscribe to our other Dan on Tech channel playlists as well. Thank you.